Hi friends, we're looking at section 12.6. We're going to be talking about a few sections today. Let's start with 12.6, rational expressions with like denominators. So here we have two examples, example 1 and example 2. We're dealing with like denominators in a situation where we're going to add these two expressions that are rational expressions. Well, just like when adding fractions back in the day, you know that if you have two fractions with a common denominator, that you just add and you keep the denominator the same. You add the numerators, that's the top part, and you keep the denominator the same. So in this imagined case, you would end up with, outside of my thought, 5/6, right? If we reduced it. We're going to have a similar situation here. We've got common denominator, so in a sense, we basically have 3n plus 7n all over 12. When I add those together, I get 10n over 12, and I can reduce this rational expression. Since 2 goes into the numerator and denominator, I get 5n over 6n, over 6 rather. So that would be my final answer. Let's look at this next problem. Similar idea. Common denominator, x plus 1. So x plus 1 is the base that everything will go over. So in the numerator, I've got 2x plus 2. What I like to do when I have these problems that we've done before is we factor as much as possible to see if there's anything we can cancel out. We find that we indeed can cancel out x plus 1, and our final answer is 2. This next example, I've skipped example 3. This next example, example 4, has the same idea, but watch this. Since x minus 2 is the denominator, those parentheses aren't necessary there, but I could put them there. I have to put in the numerator both of these numerators. So watch this, 3x plus 4, but this subtraction sign is subtracting the entire expression, x minus 1. So here, a parentheses or a pair of parentheses is essential. So now that I've rewritten this correctly, again, my denominator is still just x minus 2, but my numerator is 3x plus 4 minus x, this negative is being distributed through, plus 1. I'm going to simplify by joining like terms together. So 3x minus 1x will leave me with 2x, and then 4 plus 1 is going to be 5. So my numerator is 2x plus 5 over x minus 2. There's no way to factor this, so I'm confident that this is my final answer. So sometimes the denominators are not exactly the same, like in this example 5, but they're a real quick fix in a sense. And so this is kind of a nice step into the next section where we're going to be dealing with denominators that are not the same. Well, here, the denominators are so close, it would be so nice if we could do something about it, and we can. What you do in a situation like this is you factor out a -1. Back in the day when I was a kid, I used to call it the magic of -1 because I thought it was awesome and I was really cool. So factor out a -1, you end up with -1 times m minus 9. You see that? Because -1 times m gives me that -m, and -1 times -9 gives me a +9. Move things around, that's what you get. But you still kind of have this awkwardness to your problem. So generally that -1 would get transferred to the numerator. So you would rewrite something like this as 2m over m minus 9 minus 4m over m minus 9. Because when I factored out that -1, everything here became negative. And so this became like a negative subtracting. All right, so now that we've got a common denominator, we proceed as usual. We have in our numerator 2m minus 4m, which is a -2m over m minus 9. For those of you who are like super into math, yeah, I see you. You might say, well, can we change the denominator back because this negative is hanging out here? And yeah, that's the same as +2m over 9 minus m. Think about it. All right, so we have literally done the first section I wanted to talk about. Let's move on to the next section, which is 12.7, where we're going to talk about rational denominators, rational expressions with unlike denominators. So the first thing the text has us doing is kind of remembering this concept of least common multiple. So basically, what I think about least common multiple, I think about the smallest number that both of these numbers can divide into evenly, right? The smallest number that both of these numbers can divide into evenly. And so what is helpful sometimes is to see this whole thing factored out. So I'm going to do us a favor and write this as 3 times 5 times m squared times b to the third. And I'll write this as 3 times 6 times m times b squared, but I'm thinking that let me make everything all kinds of super prime factories. So let me go ahead and change this 6 to a 3 times 2. You guys remember doing this, right? So I'm going to put a 3 here and a 2 here. So 2 times 3 is still 18. You guys see what's happening? Okay, cool. So I factored both of these completely, and I'm looking for the least common multiple, the number that each of these can divide into evenly. And so I'm going to kind of create this like Frankenstein. I know that the number I'm looking for needs to contain a 3 and a 5 and an m squared and a b to the third power to include this, right? But I also needed a 2 and another 3. So I'm going to put a 2 here and a 3 here. Are you guys with me? So I've taken care of this. I've taken care of this. Is an m involved here? Yes, I've got m, so I don't need to cover that m. Is b squared involved? Yes, I have a b squared because I've got b to the third power. Here, I know that all of the values here have been covered, and now I can write out this number. So this number that definitely includes all that we're looking for is 90. Not 3 times 3 is 9, 5 times 2 is 10. 90 m squared b to the third power. So I've created a number that includes all of the other numbers. So 15m squared b cubed, I don't know why I can't say numbers, is definitely in here, is definitely divides evenly into this, and so does 18m b squared. And I made sure and in a sense tightened it so I would only have exactly what I needed to contain those two numbers. All right, let's go ahead and do the same thing here. Sometimes we need to find the LCM of polynomials, right? And so that requires us to factor. So we're going to do a little factoring here, see if we can factor, hoping that we can factor so we can really see what the numbers are made of. And in this case, I'm looking for two numbers that multiply to give me 15, yet add up to give me 8, and that would be 5 and 3, and both of those are positive, okay? And then over here, two numbers that multiply to give me a -6, yet add up to give me a +1. That's +3 and a -2. And so I have that. And so now if I had to find the LCM, the least common multiple, or the number that both of these can divide into evenly, so my LCM must contain all of this number, x plus 5, times x plus 3, and it must contain all of this number. It already has part of the number though. It has x plus 3 in it. It needs x minus 2. So my LCM, which I'm not in this case going to FOIL out because it doesn't help me, my LCM is this. Okay? So that practice or trip down memory lane really was to get us to a point where we can make common denominators before we add or subtract our rational expressions. So a plus 1 over a and a minus 3 over 3a is going to have a common denominator of 3a. Most of the time, we will end up just multiplying what we need in order to get the answer. So 3a contains a, so we're in a good place. No need to do 3a squared though. You see that? Since this denominator is now multiplied by 3, I'm going to multiply the numerator by 3 and get a plus 1 times 3. Since this denominator did not change, it was only multiplied by 1 in a sense, I'm just going to leave this numerator the same. So now I can write everything over the same denominator, and I'm going to distribute this through because there's not going to be a way for me to cancel. 3a plus 3 plus a minus 3. What did I mean by there's not a way for me to cancel? If I just wrote it as 3 times a plus 1 plus something, there would be no potential canceling happening. So I'm going to multiply it out, see if I can join like terms together. So 3a plus another a gives me 4a, and then 3a, 3 plus a -3, they cancel each other out. So I'm left with 3a here. What I'm going to notice is that the a's are there, and my final answer is 4/3. Let's see if we have another example that makes sense to us. All right, so here's another one. We have y squared plus 4y plus 4. I'm definitely going to factor this to see what's going on. So I've got y minus 2 over, this can be factored into the quantities y plus 2 times y plus 2. This is a perfect square trinomial. And so now looking at these problems, my least common multiple for both of these, it must require a y plus 2 quantity squared. So this fraction is going to stay the same, right? For ease of writing, I'm going to write y plus 2 quantity squared. And over here, this guy has to have y plus 2 quantity squared as its denominator. So if that's the case, the numerator changes by y plus 2. I want you to stop and think about it if that seems weird or we're going fast. And then we get to write everything over the common denominator of y plus 2 quantity squared. Okay? So y minus 2, that's the first part of this fraction. And this guy, I'm going to multiply. Plus is easy to do because it's a difference of squares, right? Y plus 2, y minus 2 gives me y squared minus 4. You guys see that? And so since I'm adding, I don't need the parentheses there. Now I'm going to join some like terms together, simplify stuff in the numerator. I've got y squared plus y minus 6 over y plus 2 quantity squared. You know I'm going to look to factor this thing. So I'm looking at it, I'm thinking I can do this, I can factor this. I end up with y plus 3 times y minus 2, because plus 3 minus 2 is going to give me that, that positive y, and then I'm going to get my 6 there. So yep, this is okay, but notice I can't cancel anything. So I would leave my answer just like this. Again, in this next example, the first thing I'm going to do is factor the denominator and see if I can see anything that will be helpful. So I have 3 times a minus 2 here. Let me move this down so I can get my numerator back in there. I haven't changed anything, so except I just factored, so I'm just moving my numerator down. And so now as I look at this, I see that they don't have anything in common. I know this a minus 2 and a plus 2 looks like it could result from like the magic of -1, but if I were to multiply something by -1, I would change the signs of both of these, and the only thing I'd like to change the sign is of the 2 in order to have some commonality. Since I can't do that, I need to make the common denominator, and that common denominator is going to be 3 a minus 2 times a plus 2. So I need to kind of put it all together. So my question to myself would be, well, what did I add here to the denominator to make it the new one? And it was an a plus 2. What I do to the denominator, I got to do to the numerator. And then I asked myself the same thing here. What did I add to this in a sense? It was 3 times a minus 2, and I would do that to the numerator as well. 3 times 3 times a minus 2. I'm going to rewrite these two fractions with their common denominators. And now, if you need to pause, please pause. If you take a look, you can see what we have going on here. And now what I'm going to do is I'm going to rewrite all of this together, but I'm going to distribute through because now is the time to see if I can make some kind of polynomial to factor and maybe factor something away. And yes, I have seen that this is a minus 2 times a plus 2, which is going to give me a squared minus 4. Maybe that'll come and give me some help a little bit later. I don't know. Let's see. So if I distribute the 4 through, I get 4a plus 8. And now I'm distributing a negative 3a. So I get a negative 3a squared plus 6a. You see that? The negative 3a and the negative 2 gives me a 6a. Joining some like terms together, I get negative 3a squared. These guys come together to give me a 10a and a plus 8. All of that is over 3a minus 2a plus 2. So I factored out a 1 after joining that all together to see if I could factor this, and I feel like I can. 3a, and I need to figure out, so this has to be a here. Only one way to factor 3, that's 3 and 1. And now for the 8, so with a little effort, I did my factoring down here, 3a squared, blah, blah, negative 3a plus 2a minus 4 goes at the top of that. And even though I was able to factor, nothing nice happened. I wasn't able to cancel anything out. So this is our final answer, all right? I'm going to do one more video in this kind of series of 3 kind of lessons put together. I just want you to watch it for now, and we'll talk about it together. Take care, guys. Bye-bye.